All right, can everybody turn to this problem in the notes? I'll go ahead and pause this video while you get ready for today's lesson. All right, so little review. I know that we might have talked about this problem already, but a binomial distribution, that means you have to check the bins. This means you have to have a binary situation, meaning a success and a failure, only two options. You need to have independent trials. You have to have a fixed number of trials, and the probability of success always has to be the same. So in this TSA problem, it says that the TSA guy hits the button, and 30% of the time, the travelers have to get a body scan. So for a family of 9, the probability of success is 0.30. All right, and we reviewed binom PDF and binom CDF. Find the probability that no one in your family, so probability that R equals 0, receives the body scan. You can write binom PDF because it's 0. You have 9 family members, probability of success 0.30, and I have 0 successes. Okay, now that will also be 0.7 to the 9th, which means that every one of the 9 family members did not get the body scan, so that would be 70% chance. At least one of your family members is selected. Well, that's 1 minus the probability that you get 0. Okay, and for the sake of time, you guys can go ahead and type in these things for the decimals. So that's 1 minus what you got in part A. Two or less are selected. So that's the probability that R is less than or equal to 2. Well, that's a straight up binom CDF. So 9 family members, 0.3, and then 2. Less than 3. Well, guys, less than 3 is 2, 1, or 0, so it's the same. 4 or less. So that's the probability that R is less than or equal to 4. Straight up binom CDF. CDF 9.34. Okay, more than 4. That's 5, 6, 7, 8, or 9. So that'll be 1 minus part E. 3 or less. That's the probability that R is less than or equal to 3. Well, that is binom CDF 9.3 and 3. And then exactly 6, that's a PDF. 9.36, exactly 6. Okay, so just a little review about binomials. All right, so now what we can do on the next part is we can find the mean of a binomial is just n times p, the number of trials times the probability. And then the standard deviation is NPQ. And remember that Q is just 1 minus P, which is the probability of failure. Okay? All right. So when Jim, that's me, shoots field goals in basketball games, the probability that he makes a shot is 45%. The mean of the binomial distribution is the expected value of successes out of n trials. Out of 6 shots, what is the expected number of baskets Jim will make? So the expected is the mean, and that's just n times p. So you're going to go 6 times 0.45, and that equals 2.7 made shots out of 6. For 6 trials, what's the standard deviation of the successful field goals made? Well, that's that formula, the square root of NPQ. So that'll be the square root of 6 times 0.45 times 0.55. and that equals about 1.22. If I shoot 24 shots, find the expected shots made and find the standard deviation. So the mean would just be the N times P. And that is 10.8 shots. And the standard deviation is the square root of 24 times 0.45 times 0.55. Okay? And that will equal about 2.44. All right, now Chevyshev's theorem says that you could call something an outlier if it's more than 2.5 standard deviations away from the mean. Okay, so on either side. So you take the mean and you subtract and add 2 standard deviations. Okay, so we first need to find the mean for 20 trials with the probability of 0.4. So 20 times 0.4 is 8. The standard deviation is the square root of 20 times 0.4 times 0.6. And that comes out to 4.8. Would it be unusual to obtain fewer than 3 successes? Well, unusual is an outlier. And if I want fewer than 3 successes, okay, out of 20, if the probability of success is 40%, remember, we're supposed to average 8. So we're wondering, is 3 unusual? Well, to figure that out, we're going to take the mean and we're going to subtract 2.5 standard deviations. Okay? So I'm going to take 8 and I'm going to subtract 2.5 times 4.8. And you get -4. Well, since 3 is not less than -4, you would say no, 3 is not an outlier. Okay, how about this problem? USA Today reports that about 25% of all prison parolees become repeat offenders. Alice is a social worker whose job is to counsel people on parole. Let's say a success means a person does not become a repeat offender. So that's a 75% chance. Alice has a group of 5 parolees. Is this a binomial setting? Well, yes, they either become repeat offenders or they don't. Independence. We can assume independence here because, one person's parole really has nothing to do with the other. We have a fixed number of trials. She has 5 parolees. And the probability of success is always going to be 75%. Find the probability of our successes ranging from 0 to 5. Okay, so probability of a 0 would be a binom PDF 5.750. And I hope you understand that this is a very low probability. Well, that's the probability that she has no one that does not become a repeat offender. Okay, probability of 1 out of the 5. 0.75 and then 1. And that's only a 1% chance, 1.5% chance. Okay, and so I'll let you guys go ahead and find the rest of them. So you need to find 2, 3, 4, and 5, and then what you want to do is make a histogram. Okay, so the probability, these probabilities will range probably from 0 to 50, and then this would be 0, this would be 1. So this one would be a very small one, and then this one, well, actually smaller than that. You can't even really see it. And then this one's just a little bit taller, etc. And you can make your histogram. What is the expected number of parolees who do not become repeat offenders? Well, that's N times P, right? So that is 5 times 0.75. So she expects 3.75 of her parolees to not become a repeat offender. the standard deviation, okay, is the square root of NPQ, which is 5 times 0.75 times 0.25, and then you take the square root. And that's 0.968. What is the probability that 2 or more of her parolees become repeat offenders? Okay, become repeat offenders. So now the probability of a repeat is 0.25, correct? What's the probability that 2 or more become repeat offenders? That would be 1 minus the probability of 1 or less. So that's 1 minus binom CDF 5.25 now, because I changed it to become repeat offenders. And then we want a 1 here. And this equals 0.367. There's a 36.7% chance that 2 or more of hers become repeat offenders.